Greetings YouTube, this is Carl, and I'm back today to talk to you about a hydraulic reciprocation circuit, and this is made using a pilot control valve. And this reciprocation circuit, it's actually just a type of hydraulic oscillator, and this pilot control valve, which is shown by this schematic here, uses pressure applied on this pilot control port to operate. When the pressure here on this particular model is below 10 psi, it just works as kind of a straight through valve. Pressure to A and B port to tank and so on. When this port here is driven to above 10 psi, then this switches into this reverse mode. So your pump is now supplying port B, and A is dumping back to the tank circuit there. And you can think of this valve as something homologous or similar to an electrical double pole double throw relay. So if you're familiar at all with electricity or electronics, you can probably visualize that. What I'm going to do, I'm going to show you a short video of the circuit in operation. Then we'll go back to this schematic here, and I'll show you in discussion exactly how it works. One thing I want you to do is note the pressure gauge reading versus the motion of the rod, like which direction it's moving or if it's stopped or whatever. And also, toward the end of the video, the last 5 or 6 seconds of it, I pan in on the pilot control valve itself so you can sort of see what that looks like. So anyway, without further ado, we're going to switch to the video of the thing operating, and then I'll show you what's going on. Okay, I'm back here again, and once again, here's the schematic of the thing. And again, remember, as I remarked before, as long as this point here is under 10 psi with this particular model valve, we have a straight through situation. So when you first start the hydraulic pump, it's going to default to this mode. So when you start the pump, oil is flowing through here, and it goes to this junction here, and this, you're supplying this pressure gauge. You're starting to fill this cylinder up with oil and push the piston outward, and you're also forcing oil through this manually controlled pressure valve here, and your oil's flowing down through here, through this, and coming up here, and then we have a split. Part of the oil is flowing through here to try to pressurize this, but we also have a flow control valve with check bypass. Now the check valve is not actually doing anything here. It was just used by the designers of the experiment, but this check valve really doesn't do anything in this circuit. All we're relying on is this manual control flow valve here. So we're starting to pressurize this, but we've set this for like a quarter of a turn open to give a slow and continuous bleed of pressure through here and back to the tank. So while this is trying to pressurize this, we're bleeding part of that pressure back out at all times. So meanwhile, the oil's flowing in here, some of it's going out here, but it's pushing the piston and the rod out. Once this piston reaches the other end of the cylinder, the oil then reaches confinement, and because the oil is essentially non-compressible, you end up with a pressure spike due to the sudden confinement, and that's what causes that boop and the jump of the gauge reading when the cylinder's maxed out there. Once you get that pressure spike, that spike is also reflected over here through this circuit here. It temporarily drives this port over the magic 10 psi number it needs to switch this valve. So this valve now reverses. Now we're supplying oil to this B port, and we're starting to shove the rod back into the cylinder. As that's happening, even though this port A is now connected to the tank, because we're forcing fluid back here, we've still maintained some pressure here as seen by the gauge while this cylinder is retracting. But meanwhile, this is still at a lower pressure than it was when it was extending. So this pressure here is also starting to bleed off through here again. Once this cylinder is all the way retracted and the piston's back at the cap end here again, this pressure drops completely to zero because there's absolutely no oil movement at this point, and this point is also at tank potential. With no pressure here, there's absolutely no oil flowing this way anymore, so all of the pressure that was here is draining back through here into the tank. Once this happens, once this thing drops below 10 psi, the valve switches back into the straight through mode, and that's when you see the gauge jump from 0 back up to, say, about 110, 120 pounds, and this piston starts to go out again with the rod extending, and hence the cycle just continues over and over and over again. So that's how this hydraulic oscillator works. Now, in industry, there is a need in plenty of situations for a reciprocating hydraulic circuit, but it's not generally in industry done this way. There are special hydraulic control circuits that do it a bit more precisely than this, but this was just basically a lab experiment which illustrates several worthwhile and important hydraulic principles. So I hope you enjoyed the video. Thanks for watching. If you like it, please recommend and subscribe.